So welcome back to the beginner track. The next talk is in English. And we have Alex Diaz from Sysdig. Please welcome him.
Hi guys, can you hear me okay? Yeah. It's not the World Cup right now. France is playing. Kubernetes World Cup, I don't know. I'm actually happy having people here. Sorry, j'aurais pu faire la présentation en français, mais je vais faire en anglais parce que c'était déjà planifié comme ça. Alors mon nom c'est Alex Diaz, je suis avant-vente pour Sysdig et je couvre EMEA. Et la présentation que je vais faire aujourd'hui, c'est en fait un client qui m'a posé la question. So he was asking me, Alex, I have a Kubernetes cluster. What do I need to watch? What do I need to, when running containers and Kubernetes, what are the metrics I need? So I make sure everything is going well. So there's a couple of factors that are involved into this. So you have your applications, you have probably Nginx, for example, HTTP proxy, you have your Java application, Ruby, C++ application that you can write yourself. Then you have your host. So all those applications are running inside those hosts. On top of that, you have your orchestration tools. In this case, we're talking about Kubernetes. You have your containers, and you have yourself. By yourself, I mean all the input you're going to provide to Kubernetes. So let's start with the applications. So we have something we call the Holy Service Metrics that also, if you have read the book, Google SRE book, they talk about the golden signals, which is latency, traffic, error, and saturation. And why those are important? Because they tell you about your application performance. They tell you when to set alerting and how to troubleshoot when it's time to do so. In a simple way, we can summarize these as request rate, request errors, and duration. So if you take an example of Prometheus, and you want to get this type of metrics, this is the code you're going to use to make it happen. That's the hard way. So we're actually getting rate, you're getting latency, and you're getting the metrics that are related to your StatZ or GMX based on the golden signals. Or you can just use Sysdig. Via system calls, we're able to detect all your relevant metrics and display that for you with zero instrumentation. We do that via system calls again. So in this case, the first metric we're going to be using on my list, number one, is connections per second. Net request count, net response time, and net request error count. In Grafana UI, you can display in this manner. And with the Sysdig UI, the same way, this is segmented by pod name, so you have all your pods, and you're able to display, in this case, the HTTP request count. Now, there is a challenge that probably you saw also this morning when you saw the Aqua presentation, is how the services are, when you spin up containers, all your pods could be in different hosts and different data centers. And monitoring becomes a challenge. So what we do here in Sysdig is we collect the metadata from Kubernetes. So Kubernetes knows, based on the structure and the hierarchy from namespaces, deployment pods, and containers, we're able to take that information and organize for you in a way that looks like this. So all your different services spread out in all the hosts, we take the Kubernetes metadata, Sysdig metrics, and we put it into a service. So now you're monitoring not just a single pod. We made an abstraction of the physical layer. We have a logical layer, which is your service. And we're able to provide the metrics based on that. Here you see, for example, different metadata labels. You have the shopping, the tier API, social, search, for example. And then the way we're going to organize this is in a different way. Now you see here, you have the service name. These are all your services name running different pods that could be in different servers. And now the same metrics we from the golden signal, we're able to see here HTTP request count. Let's talk about the legacy metrics and make the difference between health and state metrics. So the health metrics we always needed all the time is CPU, memory disk, connections, response time, and error. We have a host, that will be the metric we'll need. But we also need to understand the states of Kubernetes. Are the containers running properly? Do we have enough resources to run those containers? So what we have in Sysdig, we have implemented and we understand the kube state metrics with zero configuration. So you can calculate and understand the state metrics from Kubernetes and calculate new metrics based on that. So once you are using an orchestration tool, you have to make sure you deploy a container given those requirements. So you have to make sure you are able to plan accordingly and be able to adjust your capacity for your infrastructure. There's more complex type of telling the services where to run, and that's affinity, taints, and toleration, but which I won't talk right now. But that's a link if you want to deep even further. So my fourth metric that's really important is node availability. What you need to know is once you spin up services, you want to know which ones are successful or not. You want to know which ones are ready, out of disk, memory pressure, disk pressure, and network unavailable. These are essential for you guys to make sure that your deployments are successful. With Sysdig, you can do it just by doing this. Basically, you say, show me all the nodes that are on schedule that are different than 0 for the last 10 minutes. You can also set the container limits, hard code them in terms of CPU and memory. And these are the metrics that you need also that are important for you to understand when running Kubernetes. This is based on the experience we have with customers and how they manage their own clusters. So in this case, you have capacity, how many allocable pods you have, memory bytes, and core. Basically, capacity minus use is whatever you can allocate. And that metric is really important. Also, monitoring ephemeral disk usage and persistent volumes is other metrics you will need. These resources. Persistent volumes are a bit tricky at this point to monitor with Sysdig. Any other tool, you can see the challenges in this post. For other type of file system that are mounted in the container, you can actually get it from Sysdig using the FS. Something to also keep into consideration is how Kubernetes is going to organize all the information and all the deployments and resources. As you are probably familiar with all of these, replication controller, replica set, deployment, daemon set, and stateful sets. So that was, in order to do that, you had to understand what actually Kubernetes is actually doing. And it's actually, you have to understand if everything that is being deployed by Kubernetes is successful, and if actually your pods are running based on that. So in this case, you're monitoring deployment replicas available. If it's under 1, means there's no one supporting your deployment. You can have 3 or 4 depending on your need, but basically have 0, you may have a problem. That's something to monitor. We have also the concept of desired instances, which is my #1 metric. It's basically how many you are supposed to have to deploy your service. In this case, you have you can specify how many replicas are running at a given time, and you can set different multiple alerts based on a deployment and namespace. Now, metric number 10. Update glitches. These are more advanced metrics, but sometimes you need to know is rolling update maximum available, and the spec has been paused. So these are the metrics you can also monitor with Sysdig. Now let's go back a little bit and talk, probably you have seen this before, you know how this works, but just a reminder what the container lifecycle looks like. Well, as soon as you do Docker run, and this is the first time you're going to deploy the application, this is what you're going to go through. So you pull the image, you create the Docker, it goes into a pending state, a starting state is ready or fail. Understanding this is important because as you deploy your services, it could have a problem at every single stage. So how do you monitor that? So we have a concept called Liveness probe that actually tells you once your container is ready, in this case, port 8080, the custom header and you get a response back means it's ready. There is readiness probes, means sometimes your containers, they have to do some more processing before actually be able to handle the traffic. Basically, the first step is, yeah, I'm ready, but then probably you have some scripts in the background running. This is when you need to do this one. So you said, once you actually ready to accept the traffic, you can go and get on this one. And this is where we come to the number 11, pod status. So we want to monitor if your pods are ready, if they're waiting, running, terminated, and ready. Probably you have seen this before. Pod restarts. So this is if I use Prometheus Alerting Manager, this will tell me when there's a problem when I actually restart in a pod. You can do that, or you can do this with Sysdig. So basically, CrashLoopBackoff. This is kind of hard to troubleshoot sometimes because all you can do is cube logs. Probably sometimes you can do -p or describe, and whatever you're getting is almost minimal. And you want to know when, if this happens, you want to be aware of it. With Sysdig, you can just set out this alert. Also something really cool, you can troubleshoot it with Sysdig Inspect. Go all the way to the traces, but after every single system call, you can see every time that process that failed, that went into that crash loop interface, did the write to file system, connected to the intranet. Even if that container never started, you can actually track back to that. There's a really good post on it on the internet, so I encourage you, you can actually go and check it out if you want. The other pieces that are really important too is Kubernetes itself. So we have the APIserver, KubeDNS, Istio, Container Registry, and any other piece of Kubernetes that needs to be monitored. So 13, the APIserver. This is basically, you still use the golden signals, and you can look for latency errors for this particular metric. In Istio, you can also, the response time could be percentile time, request time percentile 99. And if the metrics are already explored with Prometheus, it will just scrape them automatically with 0 configuration. And one of the last metrics that is super important is what do you actually do when you do CI/CD and commits and you do your manual deploys, is what are you giving to Kubernetes? You have to make sure it's valid. And I give you a couple of tools you can use here. Is kubeeval, kubediff. There's more discussion about how can reconcile that and have some automation on that. So I want to recap all the metrics that we believe are essential and our customers are using in large environments running Kubernetes. So that would be, again, connections per second, response time, and errors. These are your applications. Node availability, CPU resources, memory, disk and external resources. How many running instances you have, the desired instances, deployment, update glitches, pod status, pod restarts. Those are the crash loops. Your Kubernetes component, APIserver health, KubeDNS issue, and monitor your own commands. Basically, all the input going to Kubernetes. And that's it, guys. Thank you so much for your time.
Thank you, Alex. So we have a lot of time for questions.
Questions, yeah. Vous pouvez poser les questions en français si vous voulez.
Merci pour le talk. En termes de priorité, c'est pas toujours facile de mettre en place 15 signaux à monitorer tout de suite. Est-ce qu'il y aurait des choses à faire en premier? Est-ce que c'est dans l'ordre?
Ça c'est difficile à dire. Ça va dépendre plutôt de ton application et tes besoins. Ça dépend si c'est une application HTTP, si c'est plus important pour toi le retour d'utilisateur. Alors ça varie vraiment au niveau de l'application et ta connaissance de ton application pour comprendre la priorité de tous les métriques dont je vous ai montré aujourd'hui. Alors ça c'est 15, c'est conseillé parce que ça couvre toutes les parties qu'il faut faire du monitoring et performance. Après c'est à vous de décider ce qui est le plus important dépendant de l'application et votre connaissance de l'application.
D'autres questions? Eh bien, merci.
Merci.